assumptions. Now the next thing we do is we calculate the VIFs for our model. And the VIF is part of the CAR package, so the CAR package has to be installed before you can run the VIFs. VIF is just a variance inflation factor. And we've never talked about this before, so let's talk about it now. A variance inflation factor allows us to test for something called multicollinearity. Multicollinearity is just a big old fancy word for saying that we have highly correlated predictors, and we probably should not have them in the same model at the same time. We should delete one of them because they're highly correlated and essentially they're telling us the same story. Imagine if I was wanting to predict something for students and I threw their ACT and their SAT score in the same model. Well, there's a reason, because both are nationally recognized academic achievement scores. You would suspect that they'd probably be highly correlated. If my VIFs were extremely high, and high is above 5 or above, that's the caution, that's the red flag, then we would probably need to delete one of the variables and either replace it with something else, or maybe just, if we've got like 3 or 4 variables, and let's say we find 2 that are highly correlated, let's just say we have 4 predictors, then just delete one of the predictors that's highly correlated and run your model with 3 predictors instead of 4. So that pretty much takes care of the evaluation of the assumptions. Now we get into the narrative of the model. So I can run summary of the model, and I can see that I get the following information. So table 1, which I have a lot going on down here that I'll explain to you in just a second. The first thing I run is the model diagnostic. And remember, the model diagnostic comes from the F statistic line right here, which tells us we have degrees of freedom 2 and 40, which I've reported. We have a test statistic of 29.25, which I reported, and we are statistically significant at the 0.001 level, telling me that as a set of predictors, age and HF reliably predict SSQ. Now, when I dive into the coefficients individually, I see that only one of those emerges statistically significant, and that is HF. So I tell the reader that right here, although that information is reported down here. Wait a minute, is that right? Yeah, okay. And then this sentence right here just reports the adjusted R squared. Remember, when we dive into the multiple regression world, we report the adjusted R squared, not the multiple R squared. The multiple R squared has a tendency to be overinflated as the number of predictors increases. So to control for that, there's something called the adjusted R squared that kind of tones this sucker down from being inflated down to what it should be in non-mathematical terms. So I report that to the reader. That shouldn't be BMI. What in the world? That should be SSQ. Sometimes I copy paste things from previous documents, and I didn't do it well there, did I? Okay, this table is interesting. Let me explain what's going on here. The very first thing we have up here is we have what's called a correlation matrix. So SSQ is, the correlation with itself is irrelevant, so I just put dashes right there because I don't care about that. The upper triangle is equivalent to the lower triangle. So what I do is I do the correlations there. So I would run a core test for SSQ and age. And you can see that my correlation is negative 0.13, but it is not statistically significant. I'm reporting the level of significance a little bit different in this video. because you see this quite a bit. 1 asterisk is at significant at the 0.05 level, 2 the 0.01, and 3 at the 0.001 level. This correlation is not statistically significant, so it didn't get an asterisk. Then I run SSQ over HF. And you can see that I do get statistical significance at the 0.001 level. That's the reason I put 3 asterisks right there. And the correlation coefficient is 0.76, which I reported. It's easy to do. Just do age. And you can see that we do not get statistical significance. The correlation coefficient is extremely low, negative 0.02. So the correlation matrix part is at the top. Next thing, the adjusted R squared, again, comes directly from the output. And then the model diagnostic, again, it's in the table, it goes right there. Next thing I do is I start pulling information out of the coefficients, so I can analyze the coefficients, the predictors one by one. So that information is put in this table, again, using the asterisk 1, 2, or 3 to represent the level of significance. And I run the confidence intervals for my model. And you can see where I've reported the confidence intervals under 95% confidence. There are the means, things that we reported earlier. And that pretty much concludes the write-up for a multiple regression. Now, I chose this first example for a reason. I wanted everything in the first example to go relatively well. Yeah, normality assumptions off a little bit. You'll find out that it typically is violated, to be quite honest. The QQ plot to me provides no concern for normality for running these models. So Durbin-Watson, autocorrelation, independence, and VIF, if that's something you want to investigate more, there's plenty of information out there. Keep in mind with multiple regression, I teach 2-semester class on multiple regression. There's a lot going on behind the scenes. I can't teach you everything. I have to teach you surface level stuff, just enough to where, as a health science researcher, that you could run and report the results of an MR model. So, complete transparency, there's more that we would need to do here. We need to check residuals. We need to check DF betas and DF fits and Cook's distances. But it's just not fair for me to throw all of that at you in what limited time that we have. So I have to pick and choose kind of the upper crust, the tip of the iceberg kind of stuff that definitely needs to be focused in the summary of multiple regression. Now, I think next example, I'm going to do one more example for multiple regression in this lesson. And I'm going to try to find an example where we run into major issues with like autocorrelation and multicollinearity. So we have to kind of start out with a research goal, but because of the violations of the assumptions, we have to regroup in the middle of the analysis. So I think I've got a data set in mind where I can do that. All right, so that's it. Take care.